Hey guys, so today we're talking about adding and subtracting those rational expressions. So they're fractions. How do we add fractions? Common denominator. Easy as that. I would suggest if it's not just monomials on the bottom, factor it first. After you add it together, got to factor top, factor the bottom, cancel stuff. Same thing we've been doing. Let's look at a simple example right here. We're adding, they've got the same denominator. Put them together. 13a plus 5a is 18a. We keep the denominator the same. That's how we add fractions. 1/3 plus 1/3 is 2/3, right? You don't change the denominator. Now we do have to simplify this. So if you want to, you could, split it up, 18 over 4 and a over 8 squared. But this one's really small, nice and easy. 9 and 2. A is going on the bottom. That's a 9 over 2a. Easy one right there. Let's look at another example. This time we have a binomial in the numerator and in the numerators, plural. We do have a common denominator, so we can literally just put them together. We're subtracting. That means we're distributing that negative to both of these. If it helps you, write it out. I'm going to distribute the negative to the 7x and the 2. And again, we have a common denominator of 16. Combine like terms. Now, like I said, we've got to factor the numerator. We've got a GCF in here. 2 times x plus 5 over 16. 2 and 16, well, those simplify. 2 divided by 2 is 1. 16 divided by 2 is 8. This is x plus 5 over 8. Now I'm going to leave it like that. You could split it up. I'll accept both answers. But this is perfectly fine for me. Number 3. Here we go. We do still have a common denominator, so we just combine like terms. We're adding, so no negative to worry about. Distributing, so I'm just going to combine it. Y squared, no more y squareds. 8y and 2y makes 10y. 21 is just by itself there. On the bottom, y squared minus 9. Doesn't this look something familiar? Factor. We got a trinomial on top. Use the AC shortcut. A times c is 21. We need those that up to 10. Know your math facts or figure them out. 7 and 3. A is 1 in this case. So 7 over 1, 3 over 1. So the numerator is going to factor as 1y plus 7 times 1y plus 3. That's your coefficient, that's your addend. Denominator is a difference of squares. Hope you recognize it. If you don't, get to recognizing them. Cancel what cancels. The y plus 3's cancel. Don't try and cancel the y's here. No, this is one thing right here, y plus 7 and y minus 3. Can't cancel the pieces. Just write it down and you're done. Y plus 7 over y minus 3. Let me do this. Hopefully you can hear me. I don't think my speaker volume affects the microphone volume, but if it does, oops. Now we're subtracting here. So this is a negative 16a squared. So that's going to be 1 minus 16a squared. Because our denominators are the same. If they weren't the same, we'd have to fix that first. Now again, we need a factor. I recognize this. It's got 2 terms, so I better be checking for one of those 3 special things. Difference of cubes, sum of cubes, difference of squares. We got difference of squares. 1 minus 4a and 1 plus a 4a. Denominator has a GCF of 3. That's 4a minus 1. Aha. These are the same except in reverse order, so I can cancel them. as long as I realize that it's a negative 1 that they cancel to. Where we can factor out a negative 1 here, and it will become this 1 minus 4a. I like to put my negative 1, it doesn't matter if you put it on the top or the bottom. I prefer to put it wherever I have a monomial. I have a 3 here, I have just a binomial up here. I'll stick it down here and stick it on the end of the 3. So on the numerator, 1 plus 4a. Denominator, negative 3. And again, you can leave it like this for me. You could rewrite it as this. Either of those is perfectly fine by me. All right, number 5, still a common denominator, but this one's getting a little more interesting. Oh, 1 second. All right, sorry about that, I'm back. Here we go. So distribute that negative. If you need to, you can write it out, or you can do something like this, turn that into a plus, that's a negative, and that's a negative. Whatever you want to do. You could even put the little negative right here by the 1, whatever. If you need to write out the whole step, then write out the whole step. Either way, since they do have common denominator, I'm going to go ahead and combine my like terms. And then we're going to factor numerator and denominator. So this chapter is going to be a lot of factoring. AC method, I'm just going to do it in my head. You can write it out if you need to. That's going to be n plus 4 and an n minus 2. AC method again, that's going to be an n plus 3 and an n minus 2. N minus 2's cancel. We've got n plus 4 over n plus 3, the end. Now let's see, is the next one still a common denominator? So even though we have a long denominator, they are the same. So let's combine like terms here. 14k squared minus 7k over, so they were the plus, so we just have to combine like terms, our denominator. 6k squared minus 5k plus 1. What? Not sure what I was writing there, but that's not what I needed to write. Minus 5k. There we go. Factor. GCF on top, 7k. 2k minus 1. Bottom, factor it. Let's see. That's a positive. That needs to be negative. So both have to be negative. 2 and a 3 makes 5. 2k plus 1. Or minus 1, sorry. And 3k minus 1. I'll go ahead and do the AC method on that one. That one's a little trickier. 1 times 6 is 6. You need to add to negative 5. Factors of 6 that up to negative 5. You might be tempted to do 6 and negative 1, but that's a positive 6, isn't it? So be careful. You have to have the same sign because this needs to be positive. So that's a negative 2 and a negative 3. Okay? So we're going to put those over A. So negative 2 over 6, negative 3 over 6. Simplify that, negative 1 over 3, negative 1 over 2. So this one, my denominator, my coefficient is 3, my addend is negative 1, 3k minus 1, coefficient of 2, addend of negative 1. That's where that came from. So that one was a little tricky with the whole negative 5 there. Might have tripped you up trying to do 6 and negative 1, vice versa. I want to show you that one. So we're left with 7k over 3k minus 1. And there we go. Ha. What do you notice here? Not the same denominator. So we gotta first get the common denominator. Now, any common denominator will work, but the least common denominator will let you simplify less. So you'll still have to simplify a lot, but least common denominator will get you the least amount of simplifying possible. Now this one's monomials. With monomials, you should be able to see what the common denominator is going to be. You've got a 2 and an x and a 3 and an x. So here's my denominator. So a common denominator. So a common denominator that will work would be 2x times 3x. That will work. I'll do it, and then I'll do it with the least common denominator. Okay, how's that? So if you want to get the least common denominator, skip ahead about a minute and a half. So common denominator, 2x times 3x, whatever the heck that is, who cares? Usually, to use a common denominator, we multiply both sides of our equation by that common denominator. There's no equal sign, there's no equation. So we're going to make this term and this term have this denominator. So what is this one missing? Well, it's missing a 3x. So I'm going to do 15 over 2x times, I need this part to have a 3x, right? So I need my numerator to have a 3x. Because what's 3x over 3x? 1. And then for the 16 over 3x, I'll multiply by 2x over 2x. Now again, this is not the least common denominator, so I'm going to have some extra simplifying to do at the end. So let's just multiply it out. 3 times 15 is 45x minus, and that's going to be 32x. We can put it over a single fraction because we now have a common denominator of 2x times 3x is 6x squared. So now, combine like terms. That's going to be 13x over 6x squared. Since it's monomials, we can kind of see 13 and 6, nothing happening there. X and x squared, x in the numerator cancels for 1, x in the denominator cancels to an x. So 13 over 6x. Okay, that's it. That's the correct answer. That'll work just fine. I'm going to redo the same problem using the least common denominator. I'm going to show you how to find the least common denominator. So you look at the factors. So if this was a binomial, you'd look at their factors. This is just a 2 times an x and a 3 times an x. So 2 times x, 3 times x. Well, I've got a 2, so my least common denominator. I need that 2. I've got 1x, that's the first power. I've got a 3, I need that 3. I've got an x to the first, oh, I've already got x to the first power, don't double up. That's my least common denominator, 6x. Okay. So on the previous one, our common denominator was 6x squared. Not that big of a difference on this one. I'm gonna make this have a denominator of 6x. But what am I missing from this one? I'm missing a 3. Very similar. On this one, I'm missing a 2. Multiply. And you get your 13 over 6x. And notice we didn't have to simplify. We didn't have to cancel the x out. On this particular example, not a big difference. On a longer problem, it can get to some serious simplification issues. So I'd suggest trying at least to find the least common denominator. On the rest of these, I will be finding my least common denominator. But a common denominator will still work. You just have more work to do. So like on this one, my least common denominator. First step, make sure you have a common denominator. If you don't, get it. I've got an a squared, so I need that, obviously, a squared. On the next one, I need an 8, okay? I need an a. Oh, well, that a squared's got a covered, right? That's a times a, so there's already an a in there. I don't need to double up. Okay. And what's this one missing? So you do not have to show every step. I think you'll be all right adding and subtracting fractions if I just go right here. What's this one missing? I need an 8, right? So I need to do 8 times this one and 8 times this one. So I'm gonna just call that 32. A's. What am I missing on this one? I'm missing an a. I need it to be a squared, so I need to multiply that by a. So I got to multiply the top by a. Because remember, if we divide the same thing we're multiplying by, we're not changing the value, just what it looks like. 8 divided by 8 is 1. A divided by a is 1. Plus, of course, a is 0, which then this problem exists, but whatever. We're going to assume in all of these cases that our variable is not going to be 0. If it is, then we have issues and we're not worried about it. Our denominator is not 0. Don't worry about that. So minus 7a over our common denominator of 8a squared. 32 minus 7, well, that's 25. A's over 8a squared. Now this time we do still have to simplify. You still have to check for simplification even if you use the least common denominator. But if you were to just multiply these together, it would be a squared here and a cubed down there, and it wouldn't be much of a difference on this one. But again, later down the line, it can be a huge difference. Sorry if you're ADD or OCD, yeah, whatever. One of those issues. I'll make it all blue for you. There you go. Yeah, that still didn't work, whatever. 25 over 8a, and we're done. Go to the next problem. Okay. Here and here, we had monomials. Now, we're dealing with binomials. We're dealing with binomials in the denominator. To find your LCD, factor first. Denominators, not numerators, just denominators. Factor your denominator. Okay, this one, I'm gonna just do it right underneath the problem. They've got a GCF of 5. Oh, hey, look at that. That makes our lives a lot easier. So now my least common denominator is, I need 5 times k minus 2. Leave it factored. Remember, at the end, we might have to simplify anyway. Leave it factored. On the next one, I need k minus 2. Got it. So this first one's not missing anything, is it? So just keep it as is. I don't need to multiply this by anything. What's this one missing? A 5. Multiply that by 5, so I multiply that by 5. That's a negative, so minus 20. If you need to do it in multiple steps, that's fine. Do what you got to do. Combine like terms. Factor. See a difference of squares here. Lots of factoring practice for you. Didn't learn it the first 3 dozen times we did it. Maybe you'll learn it now. Cancel stuff out, cancel stuff out. K plus 2 over 5. And I'm going to leave it right there. You can put k over 5 plus 2 over 5, or you can leave it right here. I'm going to leave it right here and move on. All right. So again, first thing you want to do is factor your denominators so you can find your LCD. This is a trinomial. That means we use the AC method to factor. Or if you're good, you can just do it in your head real quick, like y plus 8 and y plus 3. If you're not good and you don't know your math facts, that's fine. Do the work. Make the algorithm happen for you. 1 and 24 ain't working. 2 and 12 ain't working. 3 and 8, there we go. Put them over A. Coefficient addend, coefficient addend. So y plus 8, y plus 3. What's my LCD? Well, I need a y plus 8. If I have a binomial, I'd highly suggest putting it in parentheses so you know that's one thing. All right, I got a y plus 8 on this first one. What do I need on the second one? A y plus 8 and a y plus 3. You're taken care of already, so I just need to stick a y plus 3 on there. So that second term, well, yeah, I guess it's a term. Yeah, it's the second term. Doesn't need anything new, just this first one. And it's kind of squished right here, so I will go ahead and write it out. I need to do 7 times y plus 3, right? Because I need to do this times y plus 3. I got the y plus 8. I need to do y plus 3. Multiply by top and bottom. Now, this is the first one. I didn't change it. See, it's 7 over y plus 8. These would cancel. But now I have the same denominator here, so I can just add this 35. Because it's got the same denominator. That's how we add fractions. We got the same denominator, you just add the numerators together. Your denominator is like your units. 1/2 plus 5 halves is 6 halves. It's like a unit, but instead of halves, we have polynomials. Is distribute, combine like terms. I'm gonna do that all in one step. That's gonna be 7y plus 21 plus 35. So 7y plus 21. Well, that's just late at night. I'm very good at making arithmetic mistakes. 7 times 3 plus 35 is 56. You can guess what we got to do next. Leave it factored. Don't distribute. Come on now. So I saw you. You were going to distribute that, weren't you? Mm-hmm. No. Factor. Leave it factored. Because look on the numerator. We factor out that 7. We're left with a y plus 8. Uh-huh. See, told you should have left it factored. Sorry, I'm old. There we go. 7 over y plus 3. Done. Nothing else we can do to that. Move on. And let's see here. Anything interesting? I guess I do. Yeah, I'll do it. So if we factor this first, I'm just going to go ahead and do the factoring in my head though, guys, because I'm just doing the AC method up here, okay? Nothing fancy. It's really easy to do that in your head if you have a 1, because it's just factors of 6 that add, because that's a positive, to get me 5, 2, and 3. Done. So I got an x plus 2. I need a stick. Well, what's my LCD? My LCD is, well, I need this right here. X plus 2. I also need an x plus 3 for that first one. Now my second one, I also need an, x plus 2. I already got that. Good. Move on. Let's go. What are you missing? You're missing an x plus 3. So what I do, the numerator and denominator must be the same. Oh, Jesus. I'm multiplying 1 times x plus 3. What on earth is that? X plus 3. So we can go ahead and add that together. X squared minus, no, plus x, put it in order. A -5 and a +3 makes a -2. X plus 2, x plus 3. Hey, look, the top has 3 terms, AC method. That's going to be x plus 2 times x minus 1 over x plus 2. If you need help on the AC method, go watch the other 100 videos on it. Cancel, cancel. X minus 1 over x plus 3. We did several examples already. Should be all right with it. Not, figure it out. And you should recognize the denominator here is a difference of squares. M minus 2 times m plus 2. So we've got a common factor here of m minus 2, so let's not double up on it. Should I do it? No. You could double up on it, but then you're going to have just a terrible time at factoring later. So just save yourself some headache and factor first, find the LCD, and then, and only then, multiply and add and whatnot. M minus 2, m plus 2, that's covered. This one needs an m plus 2. So you can save yourself a little bit of space by distributing now 2m plus 4. Okay with that. Do some sort of weird equal sign thing if you want. I guess I should write that there too. Yeah, that's m plus 2. Believe it or not, I don't believe it. Combine like terms. M squared plus 7m plus 10. Another nice and easy factorable numerator there. Trinomial AC method if you don't know it off the top of your head. Factors as m plus 2, m plus 7. That. We got some cancellation note going on over here. And we are left with m plus 7 over m minus 2. Okay. And where these we got? Okay. Well, we can do this. We can do this. I don't have any common. I can't factor this. There's no common terms. What do I do? What do I do? What? Oh. My LCD is just the same as my CD. Put it in parentheses because it's a binomial. We're multiplying here. This thing times this thing's my common denominator, my least common denominator, in fact, because I can't do any kind of factorization here. No GCFs. It's 2 terms. It's not a difference of squares or anything. Got to just stick them together. This one I am going to write out a little bit extra. I know I'm going to need a stick W minus 7 on this one, and a W plus 1 on this one, because we need a W minus 7 over here. Doesn't matter which side you put it on, by the way. W plus 1 over here, so that we have our nice common denominator going on. There we go. You can distribute here, or you can rewrite it, whatever makes you happy. I'm going to distribute now. 5W minus 10. I would at least distribute and then combine like terms, though. Oh, a lot of students, for some reason, like to just do the numerators and then at the end magically make the denominator appear. Don't do that. Sometimes you forget the denominator, you just do some weird stuff with it. So every step, write it as a fraction. It's a rational expression. Leave it as a rational expression. Don't try and make it a linear expression that turns into a rational expression magically at the end. Please. I'll mark you off points. Leave a factor w plus 1, w minus 7. Order doesn't matter because multiplication is commutative. 5 and 8 makes 13. Negative 10 and 8 makes a negative 2. I don't think I can do anything with that. Let's think. 13 w minus 2. No GCF. No, nothing. But I will say you can leave it in factored form, just like this is done. It's more useful later whenever we're going to graphing so you can see your asymptotes anyway. It's not too far off, but we'll get there. We'll get there. Hopefully. All right, again, there's nothing to factor down here. Common denominator is also my least common denominator. You got a monomial and a binomial, let's put the monomial in front. Just do it. It looks nicer. So this is my common denominator. It also happens to be my least common denominator. So I'm going to use it. This guy needs a b. This guy needs a b plus 3. B on you. Take a b plus 3 for you. All right, bb is b squared over b times b plus 3. Leave it factored. Distributive property here. If you want to, be careful. It's a minus. Let me go back and check real quick. I might have messed up. So it has minus sign. I didn't. Okay. Yeah, I'm usually decent at seeing things, but just gotta check. That's a minus. So what does that mean? It's a negative 4. It's going to be a negative 4b minus 12. Okay. We're distributing the negative 4 to b plus 3. Combine, there's no like terms. Oh, it's got three terms. So it's a trinomial. So we're gonna AC method it. Unit. Yeah. B minus 6. That's terrible. Let me try and draw very nice and neat. B minus 6. So that's not B minus B. That's B minus 6. Okay. And then a B plus 2. Those are B's. See, that's why I like the variable x, because x doesn't look like a number. B times B plus 3. And if we notice, nothing cancels. We're done. Yay. See, he was trying to trick you how you thought you were going to have to divide. You have to do 3 and 4 for your 12, huh? I was thinking about it first too, but it didn't work out. So make sure you factor it. It doesn't matter what's on the bottom. You might think, oh, I got a B plus 3 down here, and that can turn into a B plus 3. Let me do that. No, not necessarily. Doesn't have to cancel. Could. It could. Doesn't have to. That one's done. Move on. Yay, this looks fun. Back to the GCF here. Hopefully this one has a P minus 5 in it. It does. Okay, good. AC method if you can't do it in your head. Just don't feel like wasting an extra 15 minutes doing AC method over and over and over again when I've already done it several times, that you can go watch it over and over again until you understand it. There's a rewind button for a reason. So let's see, what's my LCD? I need a 4. I like my numbers in front. P minus 5. That first term's taken care of. First First denominator, let's go with that. First denominator is taken care of. Second denominator, I also need a p minus 3. P minus 5 is taken care of, but the p minus 3 I don't have yet. So let's put it. So I'm going to just write an extra step. Oh. Plus I know I'm going to have the same denominator, right? Go ahead and put it as a single denominator. Oh, man. Oh, that's not bad. So what's this one missing? It's missing a 4. I thought I was going to have to use the distributive property and then factor it, and then, yeah. Yeah, I didn't have to do that. You might, but this one didn't. 2p minus 6. Well, it's the distributive property, but I thought it was going to be like a binomial and then like other stuff. But it wasn't. It was nice. P minus 5. P minus 3. It's a weird 3. Just ignore that extra little symbol thing. 6p minus 30. Accurate DCF. A second. So I've got 6 p minus 5 over 4 p minus 5 p minus 3, canceling stuff out. That cancels directly. 6 and 4, they both have a 2 in them. 6 divided by 2 is 3. 4 divided by 2 is 2. So that's leaving me 3 in the numerator and 2 p minus 3 in the denominator. Leaving it like that is perfectly fine by me. All right, here we go. Last one. Okay. That's got a 2. Sorry, 4. That's got an R plus 4. Okay, not so terrible. LCD. Now, I see what it's going to be, right? I've got an R plus 4 on both of them, so they both need an R plus 4. This one needs a 2, that one needs an R. There. I like putting monomials in front. I just prefer it that way. Personal preference. Is it wrong? No, because multiplication is commutative. What's this one missing? It's missing an R. What's this one missing? It's missing a 2. And yeah, you times R times 2, and then it's all the same. Yeah. R squared minus 16 over 2R, R plus 4. Difference of squares in the numerator, R minus 4, R plus 4, 2R, R plus 4. Those cancel. R minus 4 over 2R is our final answer. Yes, you could break it up. Fine, I'll do it. It's a monomial on the bottom, you just split it up. Simplify. That would be 1/2 minus 2 over R. So this would be acceptable, or this would be acceptable. I'll take either one. You can stop right here. It's fine by me. It's fine. But if you want to, you can finish simplifying it. That's it for rational functions and their Adding and subtracting them. Yeah, that. Anyway, next time we'll be dealing with more rational functions. Yay, see ya.